We're over here on the east side of the house and the east side of the garage for that matter, and this is the electric meter service below grade. And this box, like this disconnect box for the air conditioning system, see how it's sealed on three sides to help moisture from getting into the walls? This box itself should have been sealed. Now this is a recent improvement, modification, and new construction. What we're doing now is we're putting slip joints on this electric supply conduit so that it doesn't cause undue stress over here when the building moves. So I'm going to write that you don't have a slip joint. It's a precautionary thing. And by the way, none of these homes have slip joints in this whole neighborhood because they were all built about the same time and they were not doing it at that time. Another thing they weren't doing, and they don't do it just about any time, okay, this is supposed to be an 8-foot grounding rod. An 8-foot grounding rod is supposed to be buried 8 feet, not 7 foot 9 inches, not 7 foot 6 inches. Now the electrician might have, I doubt it, but the electrician could have been here with an ohm meter and demonstrated to the code inspector that it was getting enough resistance and they could stop there. That could happen. I've known it to happen at my house. That said, I wasn't here. The rule is it's supposed to be completely buried. The grounding rod's not completely buried. We're on the east side of the house, the east exterior part of the garage. And we're going to move along here. And we're going to come in here. And this is inside the east side of the garage. And we're coming in and our fluorescent tubes should have a protective prism cover. Okay, they should. Our line sprinkler system is labeled. How about that? 4 zones right there. Well, we're coming in here for this. This is the electric load center. Some people call it the breaker box or the service panel cabinet. Call it what you will. Here we are. All right, it's 150 amps. That's acceptable. What we have here is we're supposed to have protective neoprene covers on L1 and L2. If you don't know that's hot, you don't belong in this box. I get it. You don't belong in this cabinet. You're supposed to have it so that any fool would know. And then this cable coming in here, this is your main neutral. It's coming in here, it should be wrapped 4 times, not in one spot. It should be wrapped about that much with white tape. If you don't know that's the neutral, the main neutral, if you can't figure that out, again, you don't belong in this cabinet. But it's supposed to be for any fool to be able to understand. Another thing we don't have here is our bonding location. Our bonding location. Let's see if we got it up here on the water heater. And we do. Right behind the discussion plate. You see that? That's right there. That's your bonding. Most electricians can figure that out. But it's supposed to be kind of like the tape part. If you don't know whether that bonding's over there, you don't belong in this cabinet. It should be bonded right here. Now see this white wire coming in here? That's a hot wire because it's a 220 system. It's a 220 system. And if you don't know that's hot, you don't belong in this cabinet. But that should be wrapped in black tape to make it foolproof. It should be wrapped in black tape. Now something that wasn't, this home is a few years old. And so that's very recent is our 220s, not the air conditioning, but our clothes dryer and our range and any other 220 circuits that we have in this cabinet, they should be GFCI protected. It wasn't required when the home was built. It's a safety issue, so we're going to include that. Another thing we don't have inside this cabinet is AFCI, arc fault protection interruption. Another recent development in electrical that were used to make our houses safer from fire. It wasn't required, but we do not have those inside of here. Moving on along, and we're going to go down here, I see that we got 1 grounding wire, which is not uncommon. All right, again, for the vintage of the house, but it's a safety issue. By today's standards, you should have 2 grounding rods within 6 feet of each other. A lot of times, they'll put them in the wall as a UFR or something like that. But you have a single ground, just like it was built. Just like it was built, and just like it was allowed to have been built. But there's, again, standards are changing. Over here, these are our neutrals, and these are our grounds. We can double lug, double tap, some people say. We can double tap our neutrals. That's allowed because these only carry current in case of an emergency. These carry current anytime something's on. If the light's off, this is off. You turn the light on, it completes the circuit, and then this becomes energized. So these are energized quite often. And by being energized quite often, these, unlike these are not allowed. I guess you can, I mean somebody did it, but these should not be double lugged. That's a code infraction right there. They should be separated. You got plenty of spots down here to separate them. You got plenty of room to separate them. You want to borrow some over here, see how this is bonded? It's okay. It's okay. You got plenty of spots for the neutral wires to be separated, but somebody decided to take a shortcut. These cables, these dead men right here, the wires are not supposed to come past these dead men. Alright? That's there for a reason. Why do they put that there? Why do you think they put that there? This is like, had some extra plastic left over? No. That's a guideline. These cables are not supposed to extend out farther than these bumpers. They're not supposed to touch the cable cabinet like that. Okay, so these cables are coming out and they're touching the cabinet. Over here, this is where L1, L2 comes in. We've been talking about that for a while. Let's talk about our circuits here for a moment. See all these little knockouts? It's because you're not supposed to bring more than 2 cables into the cabinet at a time. And so what happens is somebody's in a hurry, they knock it out, they got a big knockout up there, they run all these cables in here, it's called bundling. And even the illustration that's baked into my inspection report, even that illustration, okay, is somewhat apologetic. I hate discounting my work, but it's somewhat apologetic. This would probably, and I would never dissuade my client from seeking perfection, but it'd be probably more practical to address this situation by when the cabinet itself is replaced. And they come in and they drop all the separate ones in like it's supposed to be. It could be made right today, but it's going to be a big mess, it's going to be a big fuss, and statistically, it's not going to make the home that much more sellable, it's not going to make the house that any more livable, and it's probably not going to change the safety factor of the house. It's a 150 amp cabinet. They're able to get away with that. All the same, you're not supposed to have debris inside of the cabinet. You're not supposed to have paint inside of the cabinet. That's a code thing. That's a code thing. That could actually void the manufacturer's warranty, which is already expired. So there's that. So, I mean, could the cabinet be a little cleaner? Yes, it could be a little cleaner. Another thing that happened is that they screwed this cabinet into place. They screwed it into place. Okay, screws are faster, screws are tighter, I get that. The screws do not have the same shear strength as nails. The manufacturer thinks that nails should have been used, okay, to hold this cabinet in place. So if this structure was to experience an event like a tornado or something, the cabinet would be more likely to stay, attached to something and as a big piece instead of a bunch of little pieces that first responders have to come through here. So it should have been done with nails instead of screws. And they quit using nails, I don't know, nails are like old school. So you go to cabinets in the 70s and the 60s and 50 and beyond, they were always nailed in. And somebody, somewhere along the line, got a way to do it faster, cheaper. And so that's just a carryover. But the instructions say nails. You're not supposed to have a gap larger than 1/8 of an inch, okay, between the cabinet and the wall. You're not supposed to have that. All right, it's supposed to fit in there a little tighter. That compromises the fiberglass thing. Now, I didn't wake up this morning and think of some kind of way that I can upset the realtor, some kind of way I can upset the builder. And I said, what am I going to do today? I just didn't come up with this idea. But this is called handwriting, right here. This is called handwriting. See where it says GE Power Mark Gold? All right, that's printing. The manufacturer and the code thinks that this should all be printed and not handwritten. It's actually a code infraction. Is that going to change your quality of life? I doubt it. And then plugs, they're supposed to be labeled specifically, and then the labeling is supposed to be printing. So it wasn't labeled properly. It wasn't labeled, and the labeling was not printed. And that's a code thing. I'm sorry. So what we learned? We learned that we got handwriting instead of printing, and that they were kind of vague in some of the lettering. We learned that we got gaps in our cabinet larger than 1/8 of an inch, and our cabinet was screwed into place. We learned that we've got neutrals that are double lugged. We learned that we got white hots that were not wrapped with black tape. We learned that our neutral was not wrapped with white tape, we learned that we do not have neoprene covers on L1 and L2. We learned that we got wires touching the cabinet cover. We learned that we got bundling. We've learned that our bonding location wasn't labeled inside of here. We got a little bit of paint inside of there. We learned that our meter was not sealed on 3 sides on the other wall, and the grounding rod was not properly buried. Those are some things that we learned today.